Next up, exceptions. Exceptions are errors generated internally by your program, and we are going to learn how to handle those exceptions in a graceful manner. Let's take a look. This slide shows the scope of this lecture, which is also the scope of Chapter 10 in your textbook, Java Foundations. The purpose of exceptions is the first item we're going to really discuss, and we'll define what an exception is, the different exception methods, the call stack trace. There's a try catch block or statement, I should say. I'm very familiar with this because I've been using this in other programming languages for quite some time. Exception propagation. There's an exception class hierarchy and IO exceptions that take place when errors are generated writing to text files. Every program should have two flow paths. One would be normal execution, meaning there are no exceptions, encountered errors. And the second would be an exception execution flow. If something goes wrong, how's that handled and how's it reported back to the user? An exception is an object that describes an erroneous or invalid or unusual situation. And programs throw exceptions, and sometimes they're caught and handled by another part of the program. However, that's not always or usually the case. In Java, an error is represented as, you might have guessed, an object, but it typically represents a situation that's unrecoverable and shouldn't be dealt with in the normal execution flow. The Java API has a predefined set of exceptions and errors that can and most likely will occur during execution at some point in your experience here. So the program can handle an exception one of three ways. It can ignore it, handle it when and where it occurs, or handle it in another place in the program. And how we handle exceptions and how we continue processing after an exception is a very important design consideration. If an exception is encountered and ignored by the program, your program will terminate abnormally and it will produce an error message. This message includes what's called a call stack trace. What is that? That indicates the line on which the exception occurred and shows the method call trail that led to the attempted execution of the, I love this, the offending line. Yes, the line of code that could not be executed normally. I'm not going to load this small application into the IDE and run it, but I do want you to do that. But let's talk about where the exception would come from. If we take a look at this, are we doing anything that would cause a problem? What do you think? Maybe I will load it up into the IDE just so you could take a look. I would like you to pause for a second, take a look at this slide, and tell me where this program, very simple program, might encounter an unhandled exception, an error that would cause it to terminate. Here we have the small program I just discussed, and it's loaded up in the IDE, NetBeans, and let's run this and see what happens. Okay, so We got the output before the attempt to divide by 0, which was line 17. And then here's our call stack trace. 0 Java 19. Following error occurred, and we could trace that error back, but it's pretty simple. Denominator equals 0, numerator equals 10. We tried to print that on its own line, numerator divided by denominator. Computers do not like to divide by 0. Okay, so that generated a fatal error and the program could not continue. Now, if this is the possibility, there's several ways to implement exception handling, input validation, etc. into the initial program design to handle this, but it must be handled. This can never happen during a production run of a program. So let's take a closer look at how we could handle this type of exception and others. Our first tool in the war against exceptions is the try-catch statement. In other programming languages I've used, most recently VB, we would call this the try-catch block. And this is used to handle an exception in a program. And the line that throws an exception or may throw an exception is executed within a try block. Try block is followed by one or more catch clauses. And each catch clause has an associated exception type and thus is called an exception handler. When an exception occurs, processing continues at the first catch clause that matches the type of exception that was thrown by the program. The Java programming language has many built-in exceptions, and it's going to take 2 pages to list the built-in exceptions. But here's the first 6 of, I believe, 12. Arithmetic exception thrown when a condition occurs in an arithmetic operation, such as a divide by 0, which we just saw. Array index out of bounds exception is when you try to access an array index that is undefined outside of the range. Class not found, when we try to access a class whose definition is not found. File not found is an IO exception when the file is not accessible or does not open. IO exception is thrown when an input or output operation failed or was interrupted. And an interrupted exception is thrown when a thread is waiting, sleeping, or doing something, processing, and is interrupted. Let's go to the next page and I'll give you the rest of them. I'm not going to continue reading these to you. So the one on this page that is probably most relevant, 2 of them actually. Number format exception is a casting exception when you try to convert a string into a numeric format, int, float, etc., and it doesn't work. It fails. You'll get a number format exception. Another one is runtime exception. Anything that happens during runtime which causes a failure. So we recently discussed divide by 0, but that was an arithmetic operation error. But imagine if that denominator is initialized via keyboard input. So you would have a runtime error that would occur during runtime, not during compile time. Here we have a generic try-catch block, and the catch does not specify any of the specific exceptions. It just uses the generic exception E, and I'll show you how this works in a second. So what I've done is I've placed the code that's going to generate an error, the divide by 0 error, because denominator is 0 in this case, and I place that in the try catch block, and it's going to receive the exception into this variable E, and then what I'm going to do with the catch block is I'm going to print out exception thrown, and then I'm going to add E, which will be in a string that holds the exception type. So this will very gracefully run and not throw any system exceptions. So if I run it, here we go, before the attempt to divide by 0, and obviously this failed. It threw an exception. It went to the catch block. The exception was, there you go, arithmetic exception, java.lang.arithmetic exception, and it even gives a little bit of a description, divide by 0. And then we just continue. This text will not be printed. Actually, it will be printed this time, sorry, because we handled the exception. I should change that. This text will be printed if the exception is handled. Anyway, I hope this helps. Very, very useful. And when I run your programs, I do not want to see any unhandled exceptions. Now we're going to take a look at a program that handles specific exception types. So this program prompts the user to enter a product code, and then you'll see it tries to take tries to parse out character at 9 from the string code, which is an entire line of characters that you enter as the product code. And then it tries to parse an integer from the substring from index 3 to 7. So it's trying to go from 3 to 7 district code, and a district code should be, if the district code is greater than 2000, then we're going to have a problem. So let's just run this and I'll show you how this works. You'll see number format exception and string index out of bounds exception are two of the catches linked to the try block. So if this string index is out of bounds, if we don't have a 9th character in that string, we're going to get that, and it's going to say improper code length. And then if we can't parse the district to an integer from a substring from 3 to 7, we're going to have another number format exception. So we'll run this, and so if I enter a product code that's too short, I'm just going to put VVV. That'll be 0, 1, and 2. We're going to get our improper code length because we're going to get a string index out of bounds. It's going to try and find that character at 9. So now let's put 9 characters in. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 10. Now this will not give us a string index out of bound error. However, it will give us a number format error because it's expecting 4 digits. So from 3 to 7. So let's try this. 0, 1, 2, 3, 4, 5, 6, 7. All right. So let's, okay. District is not numeric. 0, 1, 2. I'm sorry. District is supposed to be 3, 2, 7. So let's try this. 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7. There. we didn't throw any exceptions. So we got the appropriate cast. So let's try it again. HHH00011. Let's say Y. That should give us an appropriate one. And then I believe stop quits. Okay. Number of valid codes entered 2, banned codes entered 0. It would have been banned if the zone was R and district was greater than 2000, and I never had that happen. So obviously I want you to download this code, run it, see how these exception handlers work. That's all. Thanks. A try-catch statement can have an optional clause designated by the reserved word finally. And the statements in the finally clause are always executed. So if no exception is generated, the statements in the finally clause are executed after everything in the try block is complete. If an exception is generated, the statements in the finally clause are executed after the statements in the appropriate catch clause are completed. As mentioned earlier, an exception can be ignored, can be handled where it occurs, or it can be handled at a higher level. Exceptions propagate up through the method calling hierarchy until they're caught and handled, or until they reach the level of the main method. A try block that contains a call to a method in which an exception is thrown can be used to catch that exception. Next, we'll take a look at a Java application that demonstrates exception propagation. So first, we have this class called exception scope, really straightforward. It has 3 methods, void level 1, and void level 1 just prints level 1 beginning, and then it has a try catch block, and within that try catch block all it does is call level 2, which is another method in this class, and you'll see it tries to catch arithmetic exception. So let's take a look at level 2. Level 2 simply prints level 2 beginning and then calls another method level 3, and then in level 3 we actually have an error. We've got the same error we've been dealing with, numerator, int numerator 10, denominator 0. We print on a line level 3 beginning, and then here's where we have the divide by 0 error. Now remember, the call to level 2 was in a try catch block, and then that method called level 3. So I've already run it. I'm going to run it again. So we have this application that creates a new instance of exception scope named demo. Within main it prints program beginning, and then it demo.level1. Demo.level1 means that object, that exception scope object, calls level 1, and here we go. So level 1 has the try catch block, it calls level 2, and here's all the error messages, and then level 2 calls 3, and the error doesn't occur until level 3 method is called. So level 1 beginning, level 2 beginning, level 3 beginning, and then there is the exception. Okay, where does that come from? Let's take a look at level 1. Okay. The exception method is, a message is divide by 0. Okay, problem.getMessage. And then later we got problem.printStack. And we'll have the call stack trace, printed on a line by itself, and then we will call the method print stack trace, which will give you all this good stuff. Of course, I'm going to put this in the timeline in Canvas, and I expect you to download it and run it and understand how these exceptions are propagated up until main. And if you look real closely at these line numbers, it tells you it happened at exception scope dot level 3. Okay, line 54. There's the actual error. Then it propagated up into exception scope level 2, line 41. Line 41 was the call to level 3, and then level 1, line 18. Line 18 is in the try catch block, and that is the call to level 2. And then main 17 is the initial call. Thanks for watching. There is an exception class hierarchy. Any classes that define exceptions are related by inheritance, and they're all descendants of the throwable class. A programmer can define an exception by extending the exception class or one of its descendants, and the parent class used depends on how the new exception will be used. And we're going to see the hierarchy in the next slide, so just hang in there for a second. So here you could see the hierarchy. Exception is a child of throwable, and then you have all of the what I call compile time exceptions and the runtime exceptions that are children of the exception class. An exception can be either checked or unchecked. A checked exception has to be caught by a method or must be listed in the throws clause of any method that may throw or propagate it up through the hierarchy. A throws clause can be appended to the method header. The compiler will issue an error if a checked exception is not caught or asserted in a throws clause. And we're going to obviously take a look at this in a minute or two. An unchecked exception does not require explicit handling. However, it could be processed that way. The only unchecked exceptions that Java throws are objects of the type runtime exception or any of its descendants. Errors are similar to runtime exception and its descendants in that errors should not be caught and errors do not require a throws clause, which we'll get to next. Exceptions are thrown using the throw statement, and usually a throw statement is executed inside a statement that evaluates some condition to see if the exception should be thrown. So in this example, if count is greater than max, we're going to throw a new max exception, and we're going to pass that string to that max exception. And I've got an example that I've written that we'll use right now in this lecture before we go on to anything else that the author has given us. I think it's easier than the code that you get for this chapter on the throw statement. So first, we're going to create a class named myException that is a child of the exception class. So myException extends exception. It declares a private int named detail, and myException int x method. X is used to initialize detail. Then the toString method simply returns the string myException plus, with a bracket, plus detail plus bracket. Real straightforward. That's all it does. So, and we have this little Java program that doesn't do much. It just has a method named calculate that throws myException. Okay, so system.out println called calculate x. Okay, if x is greater than 10, we're going to throw a new myException and we're going to pass that integer x. Remember, there's a parameter here. So no braces, so that's the body of that if statement. And then afterward, system, if that's not executed, if x is not greater than 10, we'll skip that and we'll get a normal exit. You can see, darn, I already showed you what's behind the curtain. I have a run down there already. So here's our main. We're going to put calls to calculate with the parameter 1 and the parameter 30 in a try-catch block. And we're going to try catch myException E and then system.out.println caught plus E. So let's see what happens here when I run this. Now obviously when we pass 1, that's not going to throw an exception. When we pass 30, it will throw an exception. So when 1, that's false. So we system.out.println called calculate 1. Okay, normal exit. Called calculate 30. Caught plus myException 30. There you go. Hope this is useful. It's pretty straightforward. You can define your own exceptions, and you can use throw to manage those, to throw the exceptions. Well, throws and the keyword throw, which is, where's throw? Right here. Next up, IO exceptions. Now this should be review for everyone because I cover this material in CSC121, the prerequisite for this course. A stream is a sequence of bytes that flows from a source to a destination. In our program, we read information from an input stream and write information to an output stream. Obviously, a program can manage multiple streams simultaneously. There are 3 standard IO streams. System.in, which is our standard input stream. System.out, which is our standard output stream. System.err, which is our standard error stream. That's the output for error messages. We use system.out when we execute print line statements or print statements. System.out and system.err typically represent a particular window on the monitor screen. System.in represents keyboard input, which we've used with scanner objects. We've used scanner objects to solicit input from the keyboard and also from text strings and other sources, other input streams, if you will. Next type of exception we're going to look at is an IO exception, and this is a checked exception. So operations performed by some of the input-output classes are capable of throwing an exception. some examples. You're trying to access a file that does not exist, or the program might not have access to it. It might not have a clear authenticated path to that file, or the file might exist but might not contain the kind of data that we're expecting if we're trying to solicit integers or floats from a file that has just text in it. An IO exception will be thrown. Back in chapter 4, we introduced the scanner class, which enabled us to read input from a text file. Now we need to take a look at other classes that let us write data to a text file. The file writer class represents a text output file, but with minimal support for manipulating data. Therefore, we also rely on print writer objects, which have print and print line methods available to them. We build the class that represents the output file by combining the file writer and print writer classes appropriately. Output streams should be closed explicitly. And next, we're going to take a look at a program that writes a test data file with random 2-digit numbers. Now we're going to take a look at a program that throws an IO exception. It's a really straightforward, simple program. You'll see I'm importing random and all of the classes in IO, java.io. And so here's our main that throws an IO exception. Constant max 10, int value, string file name test.txt. That's important. Hold on to that for a second. And we're going to use a print writer, out file, new print writer object, and it needs a file name to connect our output file stream. We've got a new random object named rand, and we've got a doubly nested for loop. Int line 1, max is 10, so we're going to go 1 to 10 on the outer loop, and num 1 to 10 on the inner loop. So this thing will run 100 times. Each time the inner loop runs, we're going to generate a new random, and we're going to assign that random to value. It's going to be 90 is going to be our seed, so it'll go 0 to 89, but we're going to shift it by 10, so that'll go 10 to 99. So these values will be 10 to 99, 2-digit integers. And each time on the inner loop, outfile.print will print that value, and then it looks like 3 spaces. So the inner loop will run 10 times, so we'll have 10 values separated by 3 spaces each. Then we'll print a carriage return or a new line, and the outer loop will go to 2, and we'll do it again. So we'll have 10 lines of 10 2-digit integers printed across, and they're going to be written to test.txt. I happen to have the folder that this project is in, and you'll see when I run this the first time. Here it is, and I'm going to come over here, and here's test.txt. It was just created, and there we go. And it's time stamped, and if I were to run it again, it would overwrite that file, and there's a new list of 100 random numbers. Now, so how can I make this throw an IO error? Well, here's what I could do. I'll simply make this write protected. So it'll be there, and it will not be able to be written over. And this time, when I run it, there you go. There's our IO exception. Because it could not, even though it found the file, could not write to it. This is the end of the lecture for this this topic, which is exceptions. Thanks for watching. Have a great day. Of course, you have any questions, you know how to get a hold of me. Take care.